Hi again, I'm Michael from Leo Robotics, and this is Leo, the bipedal walking robot. Well, he's not walking yet, but we've made a lot of progress. So since last time, we've had a lot of problems with Leo. I kind of short-circuited everything. We have a new processor, new motor drivers, a new power supply, I have a new way of hooking everything up. Basically, I've done a lot of work, but I've got it to the point where it was before, but there are a lot of upgrades, and I think it's going to be a lot better for the future. The first upgrade, and one that I'm really happy about, is the removal of this thing. So this is a variable power supply. My physics teacher was nice enough to give it to me, and you can change the amount of voltage that you want to come through these contacts. But the thing is, then I had to have two wires going up to Leo, and then I had another two wires that were for his Arduinos, one for the Arduino Mega and one for the Arduino Duo for programming. And all in all, it was just really a hassle. So without this, I now have this. This is just a standard computer cord. That is all I have to use to power Leo. Right here you can see that there's a computer jack. I actually have an old power supply that I salvaged this from. Literally, that will power a power supply that is inside of him, which will power a 5-volt converter, and then that will power the Raspberry Pi. Everything works off of this one cord. I'm really happy about that. Next upgrade, which I already kind of mentioned, is switching the processor. So I used to have this Arduino Duo, which is the fastest Arduino processor there is, and it was working fine until I fried it. It still runs the same code, but you can't reprogram it, so that is just a paperweight. So instead of just getting another Arduino Duo, I got a Raspberry Pi 3B Plus. So unlike an Arduino, a Raspberry Pi actually has an operating system on it you can program on it. And it has a standard HDMI port which you can plug into a type of monitor. That's not what I'm using, but it still is really useful. And it's also just a lot faster than an Arduino is. So without further ado, let's actually take a look and see what's changed on Leo. So this whole central part can actually lower down, and we can take a look at everything. So this port up at the top is where the computer power plugs in, and then we've got this power supply in his main chest. That sends wires up to this 5-volt regulator, which will power the Raspberry Pi. It also sends wires across the central area here to this distribution area to his new motor driver area, which I'll describe in one sec. Down the center here, we've got his Raspberry Pi along with an Arduino over there on the edge, and I'll explain why I need that in just a sec too. So originally I had the motor drivers sitting above the Arduino Duo on plates right here. That just didn't end up working, and it was really hard to move stuff around if I needed to, so now I have this. Main power comes in here with these very nice looking huge dollars of solder, and that gets distributed 24 volts to every single motor driver. The data coming from these pins right here comes from the Raspberry Pi, and then is distributed through each of these wires to each motor driver, which sends PWM signals to tell each motor driver how fast to move each actuator. Additionally, in case something went wrong, I installed this switch right here. This is just a simple on-off switch which I put into the power for this servo driver board. So if I switch this off, then it will turn off the power on this board, which will immediately turn off all of the PWM signals going to each of the motor drivers, thus turning off all of the actuators instantly. If we look around the front, as you can see, we have a Raspberry Pi sitting inside there, but we also have a USB coming off the Pi connected to this Arduino Mega to take all of the signals from the potentiometer feedback joints in his legs, and then send that over serial to the Raspberry Pi. So without further ado, let's power him up. So I literally just take this, plug it into its socket, and things start turning on. So we have our indicator here that's showing that 5.1 volts are being delivered to the Raspberry Pi. And then down here, we have all of the indicator lights on our motor drivers. So as you may have noticed, there's nothing connecting Leo to my laptop. That's because I set up an RMate SSH client so that I can edit the program files on the Raspberry Pi remotely from my computer, and I can start up the Python scripts remotely. So over here on the computer, I already SSH'd it into Leo, and now I can just use RMate to open up the Python file I've been working with. First is the setup area. This is where I import all the libraries that I need, and I set some variables that are going to be working behind the scenes to make sure everything works properly. The next section is variables. This is where I set all the variables that I'm going to be using for Leo, not variables that are going to be working behind the scenes. Next is the functions area. So these are all the functions that I had to define in order to make Leo work correctly. There is the off handler, so whenever I hit Control-C to stop the script, it'll make sure that it turns off all the actuators, or else they'll just continue at the same pace that they are already at, and that would break everything, so that's not good. Next is the move function. So all I have to do is call move, and then the motor I want to use, and the speed I want to set it to, and then it will turn on and off each terminal on the motor driver and set the speed using the servo driver. Next section is turn off all. This is used in the off handler right here, and this basically just goes through each of the 16 different terminals on the servo driver and make sure that all the motor drivers are set to their off position. Next is just a simple thing that I made, which Arduino already comes with it, but Python doesn't. So this is just clamp. I give the value that I start with, and the minimum and the maximum, and that will just make sure that this number is in between the minimum and the maximum. If it's not, it'll clamp it. The next function, and the biggest function, is center leg. So this takes 2 potentiometers and 2 destinations. So this is called 4 times the loop runs for each section of the leg. I input the 2 potentiometer values in each section of the leg and the 2 destinations where I want those potentiometers to be. Then I just set some variables at the beginning, and then I figure out the distance of where I want it to be and where it actually is. Then is the graph. So this is the graph maker I used in order to figure out how it's actually going to be doing all this. So only what's inside these green lines and the 2 axes matters. The first equation I tried was this. This is the next line I tried out. Literally super simple. Finally, the last graph I used was this. This is literally just an x squared equation. I mean, that's about it, and then I just multiplied it and divided it so that it would get to the point that I want it to be at here. So as it gets closer, it declines faster, and then it stays closer to 0 for a longer amount of time so that his actuators are less jumpy. So this is how I designed the graphs that I used to control Leo's actuators, and this is the graph that I stayed with, so let's get back to the code. Then after I figure out the value from the graph, I just multiply it by -1 if it's supposed to be negative originally, and then I set these global variables, which is center leg out 1 and 2, to these values, which are clamped to the height of the graph or the maximum value that you can set it to. Finally, we have the real code. This is where the loop is, and this is where everything is controlled from. So first off, we just make sure that if we push Control-C while the script is running, it will cancel all of it, and it will run the function off handler to make sure all the actuators are off. Then we set our demand positions for side to side and forward and backwards. Then we set our overall speed. This is multiplied by the end result of each value to give us a different speed setting. So if I am testing something and I'm not sure if it'll work and I might break him, I'll set him to a speed like 0.3, and then it will go slow enough so that I could catch it and stop the script before he breaks himself. Next we have the main loop of the entire thing. So in this waltzer, this thing will just keep on looping over and over again. So first thing is we send a capital R to the Arduino, and the Arduino is programmed so that when it receives a capital R, it will return all of our potentiometer values in a long array. Then after it sends the R, it will receive the data that the Arduino sends, but it will also wait until the data comes back. If it sends me 8 values, which is how many potentiometers there are, then it's good. If not, then something weird happened with the transferring of the data, and it didn't actually send me the data I wanted, so it'll try again. It'll just skip all of this. But if it sends me 8 good values, then I fix up some of the values by removing a new line and set each of the potentiometer numbers. On Leo, I use tape to write a number on each potentiometer, and that's corresponding to these numbers here. That just makes it easier for me when I'm trying to debug what's happening. After we get all the potentiometer positions, we call center leg 4 times. After we call center leg, we get the values that it outputted and set that to the value that we're going to write to the potentiometers in just a second. And then finally, at the very end of the script, we just have 8 move values. What did I blow? Dang it. So thanks for making it to the end of this explanation video. Anyway, I'm going to keep on making videos like this in the future to show how I'm making progress on Leo, and I hope to see you in the next one. Bye!